chemistry class. Today we are discussing unit 12 of your syllabus, that is organic chemistry, some basic principles and techniques. Yes, in the previous class we have discussed nomenclature, that is how to name an organic compound. Now in today's class we will discuss some terms regarding which are used in reaction mechanism and electronic effect and your inductive effect and electromeric effect. Remember dear students, it is highly important that you practice a number of problems from nomenclature, because in that way you will easily remember all the rules which are being taught to you, and you will face new and new problems and you will know how to name an organic compound. So, it is a request to all of you, please do a lot of problems from nomenclature from any standard book. So, let us start today's class. In organic reaction, the organic molecule react with an appropriate attacking reagent, and this leads to formation of an intermediate, and the intermediate then breaks down to give you the products. So, what happens? The organic molecule react with a reagent, this leads to formation of an intermediate, and the intermediate breaks down to give you products. Organic molecule, attacking reagent, intermediate. Now, the intermediate breaks down to give you products and byproducts. So, in organic chemistry, the reactants are classified in two ways, that is substrate as well as the reagent. The reactant which gives carbon to the new bond is called a substrate, or you can say the reactant under focus is called a substrate. तो तुम बही जो substrate लिखाई तो माने actually it is an organic compound on which we are focusing. Then the reactant, then the reagent is called, the rest reactant except the substrate is called a reagent. If both reactant and the substrate they give carbon to the product, they give carbon in the product, then you can arbitrarily choose the which one to call substrate or which one to call the reagent. Suppose this is an example, let us see an example. Suppose methyl bromide reacts with potassium hydroxide giving you methyl alcohol and potassium bromide. Here the carbon in the product side, that is methyl alcohol, this is coming from methyl bromide. The carbon in the methyl alcohol is actually coming from methyl bromide, hence the methyl bromide will be the substrate and this will be the reagent, and this will be the substrate. तो सबुठारु मन रखता शॉर्टकट रे मन रखियो सबस्ट्रेट कोन जहार प्रॉपर्टी को आमे स्टडी करछे, जहा ऊपर फोकस अछि सेटा होची सबस्ट्रेट, आउ ता छडा बाकी जहा भी रिएक्टेंट रहला ताको आमे रिएजेंट्स कहू. Now let us see what is a reaction mechanism. Reaction mechanism is a sequential account of each step by step कहा परे को step होची, describing details of electron movement, electron रो केमिति movement होची molecule रे, so that attack होची, energetics कौन change होची, bond formation आउ bond cleavage time रे कौन energy change होची सेटा कहा जाए energetics, and the rate of transformation of the reactant टा केते शीघ्र product को convert हेई परची, that is called kinetics, जोटा कि हमें तुमरो अच्छी पढ़ुथु. The rate of transformation of reactants into product, they all come under reaction mechanism. The reaction mechanism माने होची you know the step by step reaction, you know how the electrons are moving in the molecules, you should also know what are the changes or energy changes accompanying the reactions, and also you know how quickly the reactants are getting converted into products. These all things comes under reaction mechanism. So what reaction mechanism helps us to know the reactivity of the organic compounds and strategy for their synthesis. So why should we study reaction mechanism? Because it helps us to understand the reactivity of the organic compound. Also it also help us to find ways how to synthesize organic compounds. So let us start discussing electronic displacements in a covalent bond. The electron displacement, mark that students, all the reactions happen due to electrons. तमर सबुतक reaction, chemical reaction कोथ पे हुए electrons को चुके हुए. So it is highly important that we know why the electrons move from one part of the molecule to the other part. This is called electronic displacement in a covalent bond. So electronic displacement may occur due to the effect of a atom or due to a substituent group or due to presence of an appropriate attacking reagent. तो कौन हुए तुमर इलेक्ट्रॉन जो मूवमेंट हुए आइदर गोटे सब्स्टिट्यूएंट एटम पाई ही पारे जोटा कि ऑलरेडी मॉलिक्यूल अच्छी किंबा गोटे इनकमिंग रिएजेंट जोटा कि अटैक करिया को आसुची ता जोगु भी हेई पारे. So remember that the electronic displacement may be permanent or temporary. एटा परमानेंटली हे पारे when completely इलेक्ट्रॉन टा गोटे पार्ट रे सबले रहउथो मॉलिक्यूल रो किंबा केही जने आसिले से सेही पार्ट को मूवमेंट करथो. This is called electronic movement in a covalent bond and we will discuss one by one. This is very important, so you should understand it. So there are four types of electronic displacements, that is inductive effect, resonance, hyperconjugation and electromeric effect. So these are the four types of electronic displacement which is happening in a covalent bond. Remember that the first three these are your permanent effect. While the last one is a temporary effect. The first three effects, that is your inductive effect, your resonance and the hyperconjugation, they are permanent effect. Means they are there in the molecule, whether you take any reagent or not, they will always be there in the molecule. But electromeric effect is a temporary effect. Temporary effect माने it depends upon the attacking reagent. For example देखो किछिटा पिला थांती जो माने कि वर्ष जाक पढ़ु थांती किंतु किछिटा पिला आम भितर थांती कोन ना जो माने एग्जाम आसले बहुत शीघ्र पढ़ंती. तो एग्जाम होची कोन गोटे एक्सटर्नल फैक्टर. एग्जाम आसला पाठ पढ़ा स्टार्ट हैला पुणी एग्जाम सर जीवो सेमानक पाठ पढ़ा कोन हो जीवो बंद हो जीवो. तो एटा होची कोन दिस इज अ टेम्पररी इफेक्ट. It is happening due to an external force. But किछिटा पिला थांती से माने वर्ष जाक throughout the year पाठ पढ़ंती, that is कोन a permanent effect because that is their कोन सेमानकर सेटा habit. So we will discuss one by one. Now first of all discuss inductive effect. So what is an inductive effect? What is inductive effect? Now when a covalent bond is formed between two atoms which differ in their electronegativity, then what happens? Now the electronegative atom will attract the shared pair of electron of the bond towards itself. Jodi A और B का भितरे होची and A is more electronegative than B, ताहले A टा कौन करिवो इलेक्ट्रॉन पेयर को निज आड़ को नहीं जीवो. इलेक्ट्रोनेगेटिविटी कौन तुम्हें पढ़ी पीरियोडिक क्लासिफिकेशन. इलेक्ट्रोनेगेटिविटी इज द टेंडेंसी ऑफ एन एटम टू अट्रैक्ट द शेयर पेयर ऑफ इलेक्ट्रॉन टुवर्ड्स इटसेल्फ. तो जार इलेक्ट्रोनेगेटिविटी जिते अधिक से सब कौन कर निज आड़ को इलेक्ट्रॉन तक पुल करिवो. So as a result of this, a fractional positive charge develops over the less electronegative atom and a fractional negative charge develop over a more electronegative atom and a fractional positive charge develops over a less electronegative atom. So let us see an example of methyl chloride. Here the chlorine, we know chlorine is more electronegative than carbon. So if chlorine and carbon are bonded through a sigma bond, remember that this effect operates through a sigma bond. So if chlorine and carbon are bonded through a sigma bond, then what will happen? Now chlorine will try to pull the bond pair towards itself. Chlorine kon karibo nijo adku bond pair ta bhidibo. As a result, the chlorine will develop a partial negative charge and the carbon will develop, this carbon number 1 will develop a partial positive charge. Remember that partial positive or negative charges are shown by the symbol delta. A delta जो देखुच, the partial positive हो कि negative हो, it is shown by delta. So here what happens? It is developing partial negative charge and it is developing partial positive charge, or you can say this is behaving like a polar covalent bond. Polar covalent bond. So this is inductive effect. It is the effect as a result of which there is polarization of the covalent bond. Polarization of the covalent bond होची कि नहीं? The polarization of the electron towards the more electronegative atom. This is a permanent effect कारण chlorine रो electronegativity fix, carbon रो electronegativity fix. तो जितेबाला भी से माने एकाठी रहिबे, they will behave in the same way. So it's a permanent effect, and hence it is called a permanent polarization effect or inductive effect. तो बुझेला what is inductive effect? It is the polarization of the electron towards the more electronegative atom. More electronegative atom sigma bond रे attach थिले निज आड़ को electron pull करे. As a result, partial positive और negative charge develop हुए, and this effect is called inductive effect. It's a permanent effect and it develops in the sigma bond only. Now let us consider a chain of carbon at where a chlorine atom is attached at the end of the chain. Now chlorine atom will pull the electron towards itself. Mark karo. The chlorine will pull the electron towards itself from carbon number 1, as a result of which this carbon number 1 will develop a partial positive charge. भाव suppose तुम पाखे कौन है पैसा कमीगला कौटी खर्च कर कमीगला तापर तुम्हें कौन कर तुम्हें जाकि तुम पेरेंट्स को माग बापा मामा आउ कि ना तुम भाई भौणी समस्त पैसा आण कि नहीं. Similarly, when it becomes deficient in electron, obviously it will pull electron from the nearby atoms. So C1 will pull electron from the nearby C2 carbon which is attached to it through sigma bond. So now the C2 carbon will develop a partial positive charge. Kaiki na taatu C1 tanla, but the charge over C2 will be less than that of the C1. Similarly, now hence C2 will develop a partial positive charge. Now it is deficient in electronic charge, so it will attract the electron from C3. So C3 will develop also now partial positive charge. देखो एटा धीरे धीरे कौन होची throughout the chain एटा propagate करची, but mark that the charge over C3 will be less than C1. काहेकि ना as the distance from the chlorine atom will increase, so will be the force of inductive effect. Practically the inductive effect becomes ignorant or we can ignore it after 3 carbon. तीनटा कार्बन पर आम इंडक्टिव इफेक्ट को टोटली इग्नोर कर परिया। फॉर एग्जांपल देख तुम्हें जो रस्सी भिड़ा भिड़ी जो पिला खेलती दीटा एंड दीटा पिला पिला एकड़े गोटे ग्रुप थे एकड़े टग ऑफ वार दी जन भिड़ुवे तो टग ऑफ वार कौन जी फास्ट थाए सी पिला विल दैट पर्सन विल फील मोर फोर्स तुम्हें जिते दूर दूर को जीव कौन हम तुम ऊपर फोर्सटा सेते कम जीव। सिमिलरली द इंडक्टिव इफेक्ट जी इलेक्ट्रोनेगेटिव एटम पाखे रहबो दैट विल फील द मैक्सिमम फोर्स और मैक्सिमम इंडक्टिव इफेक्ट और मैक्सिमम पोलराइजेशन and as you move from or as you move away from the electronegative atom the inductive effect will gradually decrease. So remember after 3 carbon the inductive effect gradually vanishes or practically it is not calculated. So the inductive effect is actually inductive effect कोथ पे होचे ना it is depends upon the ability of the substituent to either gain or the ability of the substituent to either donate or withdraw electron from the chain. The substituent ability पर depend करछि. So on basis of that the inductive effect are of two types, that is plus I effect and minus I effect. So let us discuss plus I effect and minus I effect one by one. So what is minus I effect? If the substituent attached to the carbon chain is electron withdrawing in nature with respect to hydrogen, then it is called minus I effect. The effect is called minus I effect or negative inductive effect. Mandela jodi substituent ta jota carbon chain re lagchi, if it pulls the electron away from the carbon निज आड़ को नहीं जाउची ताले कोन हबो मन रखता ऑर्गेनिक रे सब बेले हमें विथ रेस्पेक्ट टू कार्बन पढ़िबा तो कार्बन ठू नहीं जाउची सेतपे कोन हबो माइनस आई इफेक्ट जेहेतु कार्बन ठू नहीं जाउची सेतपे इट इज कॉल्ड माइनस आई इफेक्ट. This is an example. The nitro group present here, it pulls the electron away from carbon, hence nitro group develops a partial positive charge, sorry partial negative charge, while the carbon develops positive charge delta plus delta plus. Remember that जिते अधिक डेल्टा लिखा हो माने ता वैल्यूटा सेते कम अधिक भाबिबो नाही. तो देखो थ्रू आउट द चेन कौन होची द थ्रू आउट द चेन देयर इज पोलराइजेशन ऑफ इलेक्ट्रॉन डेंसिटी. पोलराइजेशन होची कि नहीं. तो दिस इज इंडक्टिव इफेक्ट माइनस आई इंडक्टिव इफेक्ट. तो मन रहला कोन if an group withdraws electron from the chain or from the carbon atom, then it is called minus I effect. The inductive effect, this is a series which you have to remember. Now some groups are arranged according to their decreasing order of their inductive effect, means nitro, so maximum inductive effect, so it is placed first, minus I effect. So nitro is a strong withdrawing group in comparison to cyanide. So you have to remember the series. Why? कारण entrance रे ए type रे हमें देखिबा how the acidity and basicity is affected by inductive effect. तो ए question उड़ा entrance रे आसे, so you have to remember this series. Now let us see what is plus I effect. Just the opposite, जहाँ minus आई तो plus. जदि के if somebody donates electron to the carbon, if the group or the substituent present at the end of the carbon chain donate electron to the carbon chain, then it is called plus I. So what is plus I effect? The substituent attached to the end of carbon chain is donating in nature, then the effect is called plus I effect. See here, methyl group, remember that all the alkyl groups, they are donating in nature, that is they show plus I effect. So methyl group is donating electron to this carbon, hence it is called plus I effect. The plus I effect of some of the atoms or groups in the decreasing order is this. Remember that more is the size of the alkyl group, larger the size of the alkyl group stronger is its plus I effect. जिते बड़ alkyl group रहिबो सेते अधिक कौन करिवो से डोनेट करिवो. larger the size of the alkyl group more is the plus I effect. एटा मन रखथिबो. तो से अनुसार कोन हला tot butyl is more donating than isopropyl than ethyl than methyl. एटा सब बळे मन रखथिबो. this is also very important. और application गुडा हमें देखिबा देखले तुमे जानि परिबो why you have to remember these things. So, application of inductive effect. First application of inductive effect is that you can explain the acidity of the carboxylic acid with the help of inductive effect. Let us see. Suppose, let us compare the acidity of chloroacetic acid and acetic acid. Acetic acid कौन CH3COH, chloroacetic acid माने one of the hydrogen is substituted by actually chlorine. So, the acidity of the chloroacetic acid is more than that of the acetic acid. Why? Let us see. So, आमे acid कहा को कहू ना the compound, the easier the compound can donate the H plus ion, the more easier the compound can donate H plus ion, more easier the acidity. जे जते H plus ion सहजरे दे पारे तार acidity हेते अधिक. So now we have to compare out of this acetic acid and chloroacetic acid which can actually give H plus ion more easily. H plus ion अधिक दब माने कौन एई जिनसटा अधिक तयारी हो. That is the carboxylate ion जहार जते अधिक easily तयारी हे पारे सेटा सेते अधिक कौन हबो H plus ion दो. So you have to compare the stability of the carboxylate ion. More is the stability of the carboxylate ion, more easier will be its formation and more easier will be the formation of the H plus ion. एटा अधिक स्टेबल हेले ही एकुटिया रहबा को चाहिबो. जदि एटा स्टेबल हबनी ये एकुटिया तयारी हबो कि हबनी. So remember that more is the stability of the carboxylate ion, more is the acidity. So let us compare the stability of the carboxylate ion here. So here what happens, now mark, chlorine is an electron withdrawing group. So in the negative charge present over carboxylate ion is actually being dispersed by chlorine. ये कौन करछि नै होछि. गोटे छोटे एग्जांपल लेबा. सपोज तमे माने गोटे लोन करछ. बर्तमान तमर पेरेंट्स जानिले आ से कहले आमे तुमर लोन टा को सुजिदा मिसे के सुजिदा ताले वेदर यू विल बिकम स्टेबल और अनस्टेबल, यू विल बिकम stable. Similarly, the extra burden or the extra charge present over the carboxylate ion, the negative charge is being shared by the chlorine atom. Chlorine कौन करछि निज आड़ को नै जाउछि. ताले कौन हो स्टेबल हो ना अनस्टेबल हो. It becomes more stable. It become more stable. So remember that electron withdrawing group, chlorine टा कौन गोटे electron withdrawing group. Electron withdrawing group always increases the acidity. It is very important. बहुत थोड़ा आछि तुम्हारे एग्जाम रे और एंट्रेंस रे. Electron withdrawing group always increases the acidity because they stabilizes the carboxylate ion. हला से माने कौन करंती conjugate base टा को stabilize करंती. Acetic acid सेमती किछ होनी. So chloroacetic acid is more acidic because the stability of the carboxylate ion. Due to the stability of the carboxylate ion will be formed more, hence H plus will also be formed more. तो मार्क करो एटी कौन थिला Cl CH C double bond O minus, and this negative charge is being stabilized by this negative charge is being stabilized by this chlorine atom. Now suppose if I increase the number of chlorine atom, then what will happen? Suppose I am taking monochloroacetic acid, then I will take dichloroacetic acid, then I will take trichloroacetic acid. Let us see what will happen. So, if I take Cl, 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 this is trichloroacetic acid. Here all the hydrogen atoms are replaced by chlorine atom. So, what will happen? Its acidity will increase or decrease. So, first of all we have to see the stability of the carboxylate ion. Jodi carboxylate ion stable होची अधिक ताले acidity बढ़िबो. Suppose same example देखिया तुमे लोन करछो तुमरो गार्डियन सुजिया को राजी हेले तुमरो भाई भौणी सुजिया को राजी हेले तुमरो रिलेटिव्स भी तुमको हेल्प कले ताले तुमे कोन हबो अधिक स्टेबल हबो ना कम स्टेबल हबो. You will become more stable because here the excess negative charge is being shared by 3 chlorine atoms. Hence this ion becomes more stable. So, remember, if the number of electron withdrawing group increases, then the stability of the carboxylate ion or the conjugate base will also increase and hence the acidity will also increase. This is the acidity order: CCl3, trichloroacetic acid, dichloroacetic acid, monochloroacetic acid and acetic acid. ए क्वेश्चन टा बहुत थर बोर्ड एग्जाम रे आसी जो थे कि तुमको एसिडिटी कंपेयर करिया को पड़िबो एंड यू विल अगेन रीड दिस इन द सेकेंड ईयर दैट इज कार्बोक्सिलिक एसिड रे तुम आउ थरे एटा को पड़िबो. ए देखलो जोटा मु देखली जोटा एबे एटा देखिला समझते देख मोनोक्लोरोएसिटिक एसिड रे गोटे शेयर करथला डाइक्लोरो रे 2टा क्लोरीन शेयर कले ट्राइक्लोरोएसिटिक रे 3टा क्लोरीन एटम शेयर कले. Now let us discuss the effect of nature of halogen. Suppose this is your fluoroacetic acid, this is your chloroacetic acid, bromoacetic acid and iodoacetic acid. So which will be more acidic? Obviously which will stabilize the carboxylate ion? Suppose dekho fluorine can pull the electron more easily than chlorine. Then dekho suppose there is fluorine, then there is chlorine. So out of fluorine and chlorine, which can more effectively disperse the negative charge? Na fluorine, because fluorine is more electronegative. So than chlorine. तो फ्लोरीन कौन करिवो बहुत जोरे निज आड़ को इलेक्ट्रॉन पुल करिवो than chlorine. Hence या ऊपर ये अधिक स्टेबल हबो कारण फ्लोरीन मोर इफेक्टिवली कौन करिवो नेगेटिव चार्ज टा निज आड़ को पुल करि परछि. Hence remember that the acidity order will be fluoroacetic acid will be more acidic than chloroacetic acid, then bromoacetic acid and then iodoacetic acid. Now let us see, this is the minus I effect. I mean देखले जो minus I effect रो acidity ऊपर कौन effect पड़छी. Now let us see what is the effect of electron donating group, that is plus I group. Suppose let us compare the acidity strength of acetic acid and formic acid. ए question टा बहुत थोड़ा बोर्ड एग्जाम रे आछी ला तो एटा भल रे बुझिबो तुमे. तो मिथाइल ग्रुप्स कौन करे, मिथाइल ग्रुप्स आर इलेक्ट्रॉन डोनेटिंग, they show plus I effect. Let us see here. So methyl groups are electron donating. So they will donate electron. As a result of the donation by the methyl group, the electron density will increase in the OH bond. ये कौन दे चलची से इलेक्ट्रॉन टा देखो थ्रू बॉन्ड शिफ्ट करके कौन हबो OH भितरे ऑक्सीजन और हाइड्रोजन भितरे जो बॉन्ड अच्छी सेठी ग्रेजुअली इलेक्ट्रॉन डेंसिटी बढ़ी बढ़ी चलिवो बट आमे कोन चाहूछु आमे चाहूछु ऑक्सीजन को हाइड्रोजन टा छाड़ी के पळाओ सो जदि इलेक्ट्रॉन डेंसिटी टा ऑक्सीजन और हाइड्रोजन भितरे बढ़िबो will it be easier for hydrogen to leave the oxygen no कारण एठी यदि इलेक्ट्रॉन डेंसिटी टा बढ़ी गला हाइड्रोजन इट विल बी डिफिकल्ट फॉर हाइड्रोजन टू लीव एटा होची फर्स्ट पॉइंट देन देखो बट फॉर्मिक एसिड रे एभळा किछि हो नाही बिकॉज हाइड्रोजन इज नाइदर इलेक्ट्रॉन डोनेटिंग नॉर इलेक्ट्रॉन विड्रॉइंग but methyl case रे eta hochi methyl is electron donating hence the electron density will increase in the OH bond as a result of which the removal of H plus will become difficult. The second part is that the methyl group due to its electron donating capability it is after the formation of the carboxylate ion which we are discussing. After the formation of the carboxylate ion, suppose you remove H plus. Now after the formation of the carboxylate ion, it become the methyl group due to its electron donating, it will destabilize the carboxylate ion. Why? Suppose you think you have a loan and you have to take another loan. Gote loan karcho, a gote loan badhe karya pudla. So whether you will become stabilized, financially stabilized or unstable, you become unstable because there is already a heavy loan on you and you have to take another one. Similarly, there is excess charge over oxygen here. Suppose there is excess charge over oxygen here and methyl is already supplying the electron to the oxygen. Oxygen को से कौन करची आहुरी electron दौची. So the charge density on the oxygen will increase and hence it will destabilize the carboxylate ion. So remember that electron withdrawing group always increases the acidity, electron donating group always decreases the acidity due to their effect on the conjugate base. It is highly important, it बहुत थर entrance रे आछी बहुत थर. So it's highly important that you should remember electron withdrawing group it increases the acidity and electron donating group it will decrease the acidity. So if I say if I increase the size of the alkyl group, what will happen to the acidity? Now acidity will further decrease. Why? Because we have already read that with increase in the size of the alkyl group, the plus I or the donating effect of the alkyl group increases. So देखो the donating effect of the alkyl groups are इटा plus I effect. जितने बड़ा group होगा सेते अधिक कम करिवो donate करि परिवो. So the acidity order will just be reversed. That is acetic acid will be more acidic than एठी को group रा लगला CH3 CH2 एथि को group टा थिला CH3 एट लगला CH3 CH2. So acetic acid will be more acidic than propanoic acid than 2-methyl propanoic acid than 2,2-dimethyl propanoic acid. ये क्वेश्चन टा भी बहुत तरह आछि. Hopefully बर्तमान you are crystal clear. देखो एटा सेकेंड ईयर पाठ बट पढ़ुचे हम कोठु फर्स्ट ईयर. So it's highly important that you read this chapter very carefully. Electron withdrawing group means it will increase the acidity by stabilizing the carboxylate ion and electron donating group will destabilize the carboxylate ion. Now stability of the carbocation. Remember the inductive effect can also explain the stability of the carbocation. What is the carbocation? Carbocation is actually a reaction intermediate. Apora me padhiba carbocation are positively charged carbon atom. Positively charged carbon atoms. Okay. So its stability of the carbocation can be explained on the basis of inductive effect as well as hyperconjugation. Hyperconjugation hame pachare dekhiba. Now let us discuss how the inductive effect stabilizes the carbocation. Now let us see first को suppose तुम पाखे किसी पैसा नहीं तो तुमको तुम घरे जानले आ तुम बापा कहले ठीक अच्छे मुझे ते किसटा देदेवी तो whether you will become stable or unstable, you will become stable because your deficiency in the financial matter is कौन तुम की fulfill कला is fulfilled by your father. Similarly carbocations कौन ना carbocations are positively charged carbon atoms, so they are deficient in electron. से मान को पाखरे electron कम थाए. Now we know the alkyl groups are electron donating in nature. Mark here 3 alkyl groups are donating to this carbon, while here one alkyl group is donating to this carbon and here nothing, because we know that hydrogen atoms are neither electron donating nor withdrawing. तुमको suppose तुम फादर पैसा देले तुम मदर पैसा देले तुमर भाई पैसा देले तो तमे सेते अधिक कोन हो स्टेबल हो फाइनेंशियली. सिमिलरली जदि कार्बन को एठी जेते अधिक अल्किल ग्रुप कम करिवे इलेक्ट्रॉन डोनेट करिवे इट बिकम्स मोर स्टेबल. So remember that the stability of carbocation is tertiary greater than secondary greater than primary. तो ये हम कौन जानले एटा अधिक स्टेबल हबो than this and this. So the stability of carbocation, eta dear students, please do remember this. This is highly important. The stability of the carbocation कारण आमे जतल reaction mechanism पढ़िया पुनी दरकार पड़ियो. एटा सबुले throughout the organic chemistry तुमको दरकार आसीबो. So do remember this. The stability of carbocation is tertiary greater than secondary greater than primary. Now let us this is all about our inductive effect. Now let us discuss another effect, that is electromeric effect. As we know that in the beginning I told you that electromeric effect is a temporary effect. This is a temporary effect. So this is a temporary effect. So what happens? Now it happens only if there is presence of double bond. Jodi double bond kimba multiple bond jodi thibo, that is double bond or triple bond, then the electromeric effect will be there. So what happens here? Let us see. Now it involves the complete transfer of electrons of a multiple bond to one of the bonded atoms in presence of an attacking reagent. Now in presence of an attacking reagent, what happens? Sometimes the pi bond moves to the more electronegative atom. Example eta dekhiba eti. This is an example of carbonyl group. This is carbonyl group C double bond O. Now out of carbon and oxygen, which is more electronegative? Now oxygen is more electronegative than carbon. So oxygen will have a tendency to attract this pi electron towards itself. But in the presence of a reagent, when a reagent comes, a suitable reagent comes, the pi electron will move towards oxygen automatically. So मैंने कौन करिवे pi electron टा completely पड़ेबो oxygen ऊपर को. ताहले कौन हला? As a result of which देखो the carbon develops a positive charge and the oxygen is developing a negative charge. देखो ये complete लिखाई छे. I am not using delta sign because there is complete transfer of pi electron. Delta रे कौन होतला? सेटा partially जाउतला. माने कार्बन ऑक्सीजन अछि ता मझिरे से टिके ऑक्सीजन आड को पळुतला. But here there is complete transfer of electron from carbon to oxygen. सेति पय एठी देखो पूरा लिखा आइछि कोन प्लस एटा तो ये कौन हो कंप्लीट ट्रांसफर होची पाई इलेक्ट्रॉन रो एज अ रिजल्ट ऑफ व्हिच मन रखता पाई इलेक्ट्रॉन टा कुआडे को जीवो पाई इलेक्ट्रॉन विल यूजुअली इट मूव्स टुवर्ड्स द मोर इलेक्ट्रोनेगेटिव एटम. तो तम भीतर दीटा गोटे मोटा गोटे पतला छुआ अछन कि अधिक इलेक्ट्रॉन को निज आड़ टाणी परिबो. सपोज गोटे मझिरे तांकर गोटे कंपटीशन है मोटा पिलाटा टाणी सेमती जहार इलेक्ट्रोनेगेटिविटी डिफरेंस अधिक थिबो से कोन करिवो इलेक्ट्रॉन को निज आड़ को सब बेले यूजुअली पुल करिवो. So pi electron ta kon hobo, usually it is transferred towards the more electronegative atom, and this is a temporary effect because as soon as you remove the reagent, dekho एटी कौन है, you remove the reagent and it comes back to its original state. से कौन है ना, तुम्हें reagent टाको नहीं जाओ, से पुणी कौन है, carbonyl group है गला. So it's a temporary effect. So this effect is actually called electromeric effect and it is denoted by capital E. So reverts back to its original position. Electromeric effect is of two types, that is plus E effect and minus E effect. है I mean देखिए one by one we will discuss. Positive electromeric effect. So what is positive electromeric effect? Now in this effect the pi electron of the multiple bond are transferred to that atom to which the reagent get attached. जो कार्बन को रिएजेंट आसिक लागिवो कि सॉरी जो एटम को रिएजेंट आसिक लागिवो जदि पाई इलेक्ट्रॉन टा सेही एटम ऊपर को मूव होंती देन दैट इज कॉल्ड पॉजिटिव इलेक्ट्रोमेरिक इफेक्ट. देखो एटी कोन हला, सपोज दिस डबल बॉन्ड ब्रेक्स लाइक दिस, so now the pi electron is moving to this carbon, over to this carbon. Now suppose the attacking reagent is H plus. So this carbon becomes minus. So H plus will come to this carbon, E carbon pakku asbo. So the attacking reagent is getting attached to the atom to which the electrons got moved. जो atom ऊपर को electron move करथिले सेही atom को attacking reagent लागुची हैला. तो सेथि पई this effect is called positive electromeric effect. Negative electromeric effect कौन होगा, just the opposite. If the pi electrons of the multiple bonds transferred to that atom to which the attacking reagent doesn't get attached. जदि suppose देखा example, suppose move कला A carbon को, so this carbon becomes minus, but here the attacking reagent is minus, so it will get attached to this carbon. But bond टा भांगिला किए, pi electron नेला किए this carbon, but the attacking reagent is getting attached to the opposite other carbon atom, then at that point it is called negative electromeric effect. बुझियला. So mark करो, while if the attacking reagent is a positive one, then it is creating positive electromeric effect. हैला. देखो मार्क करो, if the attacking reagent is a positive one, then it is creating plus E effect. But if the attacking reagent is a negative one, then it is creating minus E effect. एटा होची तार short trick to remember, plus E effect. So with this we have completed our electromeric effect. Now let us start discussing resonance. Resonance is actually first पढ़ाया था 4 types of electromeric effect. What are they? Inductive effect, resonance and hyperconjugation and your electromeric effect. So out of inductive effect, resonance and hyperconjugation they are permanent effect, while your electromeric effect was a temporary one. So let us start discussing resonance. We will discuss it in the next class elaborately, but today I am giving you just a brief idea. Suppose there is a molecule benzene. समस्त benzene चिंतिवा. So benzene can be written like this, like structure 1 and structure 2. It has 3 single sigma bond and also alternate pi bonds, 3 pi bonds and 3 sigma bonds. It has sigma bond, sorry, it has your single bond followed by double bond, then single bond, then double bond, then single. So, alternate single bond and double bonds are present in the benzene. But mark that here 1 and 2, between carbon 1 and carbon 2, there is presence of single bond, while in this structure there is presence of double bond between 1 and 2. So, which should be the correct structure of the benzene? The correct structure of the benzene is actually in between these two structures. So, resonance concept quote hoila. Now, some molecules cannot be represented by a single structure, or you can say all the properties of a molecule cannot be represented by or cannot be explained by a single structure. तो ताको बुझाया पे हमर कांसेप्ट हैला कोन रेजोनेंस सेथुर आसला कोन रेजोनेंस हाइब्रिड कांसेप्ट हैला बुझियला. सो इफ यू एक्सपेरिमेंटली जो तुम देखिबो तुम कोन पाया कथा ना देयर आर 3 pi bonds. So you should get the result for double bond. यदि याकू टेस्ट करिवो तुम कोन पाया कथा you should get the result for single bond as well as double bond. But experimentally it was found that all the bonds in the benzenes are identical. किछि single bond नहीं कि double bond नहीं, सबु तो कहउछन कोन identical bonds. They are all equivalent in nature. तो एटा को केमति बुझाई परिवो ना A structure बुझाई परछि ना A structure बुझाई परछि. So there comes another structure or concept that is called resonance hybrid, and we will discuss it completely in the next class. So dear students, have a good day. Take care.